So this is going to be a quick-ish quadratics review. It's going to be the last couple units. We've most recently, when we moved to online, worked on the idea of the standard vertex and zeros form or roots form of the quadratic equation, factored form. But we've also, in the previous unit, before we went off on this extended leave from school, we did some factoring that. We're going to start connecting this all in the next unit. So just a quick review of everything. You can go back and look at the specific videos for different content if you really want a little more of an in-depth look at some of it. But I'm just going to kind of roll through this fairly quickly. So with quadratics, we're talking about our parabolas. Okay, these are parabolas when we graph them. Parabola is how you spell it out. Quadratics, there's three forms of quadratics. There's a standard form. Y equals ax squared plus bx plus c. A, b, and c are just numbers. And then we have the vertex form. The vertex form is y equals a, and then in brackets, x minus h squared plus k. Again, a, h, and k are just numbers. And in the final one, we have the zeros or factored form of a quadratic. And that form there is a, and then in brackets x minus r, and then another set of brackets x minus t. A, r, and t are just numbers. R and t, and I believe in your textbook they use r and s. It doesn't matter what letters you use, it's just the fact that there's letters there. I like r and t because my s's get confused with my 5s. So I use R and T. You can use A and B, Q and W. Even in the standard form, you can use X. Well, you can't use X because we're already using X. But you can use Q, W, and P. It doesn't matter what letters you use as long as they're different. You understand the positioning of the letters. So the number that comes out in front of the x squared, this is in front of the x squared. If we expanded this out, we're going to do some expanding later. If we expanded this out, this vertex form out, the a would be in front of the x squared. We get back to this. If we expanded this one out, the factored form out, we would get back to this. The a is the number in front of the x squared. And then in the case of b and c, the b is the number with the x, and the c is the number all by itself. The h is the number in the brackets with the x. The k is the number outside the brackets, kind of just hanging out by itself when there is a set of brackets like this. So in this kind of format where the x squared, the squared portion, is stuck over here. It's not already expanded out, and it's not being squared like the r and t. And the r and t are when we have two separate brackets with two numbers inside. So that's our r and t. So understanding the way this looks numerically, important to know. Key things. A always means the direction of opening, whether the graph opens up or down. Positive, it opens up. Negative, it opens down. Stretch and compression, meaning that if the a value is greater than 1, when we ignore the negative or positive sign in front of it, if we just look at the actual absolute value of a, you know, the distance from 0 that it is, be it left, be it right, then that is meaning that it's a stretch. Greater than 1, it's a stretch. If it's less than 1, between 0 and 1, if it's 1/2, if it's negative 1/4, that means we're compressing the graph. That graph is going to get fat and wider. And it's important to note that a is never 0. If a is 0, we do not have an x squared. If we don't have an x squared, and I'm going to cover it up here in the standard form, we have bx plus c. That is a linear equation. When we're working with quadratics, x squared is always the highest value of x2. There's never an x cubed, never an x to the 4, never an x to the 5, never an x to the 72. It's always x squared being the highest value. In the case of the standard form, the c value, if we look for the y-intercept, that's when x is 0 on a graph. Looking at this graph really quickly, the y-intercept happens when the x is 0, it crosses the x-axis. Then that's times a times 0, b times 0, we're only left with c. That's the y-intercept. In the case of the vertex form, h and k, the h is the x coordinate of the vertex. The k is the y coordinate of the vertex. Note that h is negative. Anything inside these brackets here is negative. That means anything inside the brackets, we put a negative sign in front of it, we swap the sign. It's the opposite when we remove it from the brackets and don't use it in that context. So a negative h means that things are moving to the positive side. A positive h means things are moving to the negative side. The case of r and t, both of those numbers are going to represent the zeros, roots, x-intercepts. All those terms mean the same thing when we're talking about quadratics. They're the points where the graph crosses the x-axis. Again, because they're within the parentheses, the negative sign is there, meaning everything's opposite. So negative r and negative t become positive r and t when you remove them from the bracket. So if you had a -3 and a -6, that means that when they translate to the graph, they're going to be both +3, +6, and the vice versa. It's also important to note that there are 0, 1, or 2 possibilities. Depending on the direction of opening in the graph, depending on where the vertex is located, they may cross at 2 points, as in the illustration I have here. They may cross never if the graph opens up like that, or they may come up, touch the x-axis, and bounce off kind of like that. So these are the different scenarios that are there. Given, and let's just get rid of these so they're not in the way. Given a quadratic graph, some of the key features that you will find on there. Right here at the starting at the top, we have the vertex. The point where the graph changes direction is the vertex. And we often note that as the HK value. HK, not HH. HK value. So the H and K will illustrate where the vertex is. This next point coming down, and we'll move down in the vertical direction here. This next point here is crossing the y-axis. It's the y-intercept. That's that C value. These next 2 points in line here are both the x-intercepts, roots, zeros, R and T. Does it matter which is R, which is T? Not at all. They could both be a negative number. They could both be a positive number. This just happens to be a graph of a next term parabola that is opening down. So this whole graph here is called a parabola. It is a symmetrical U-shaped graph. Why is it symmetrical? Because we have this axis of symmetry found at the location of x equals h. H being the h value of the vertex, x equals h, meaning that we have a vertical line going straight down the graph. And we have that old school idea from grade 6, I believe. That's when I used it. Red mirrors. We'd plot this red mirror down on the page, and we would get a mirror image, a symmetrical image of whatever was on the other side. As we look through it, we could trace it out and make mirror images of things. So these, if you remember the red mirrors, that's what we're working with here. If not, it just means that the graph, if you fold it at that point, if I took my page and folded it there, those two sides should match up. Probably not in my diagram because my drawing is not the best. Okay, so we've gone over the 3 forms, we've gone over the key features. Another important idea to note is the idea of square roots. Again, you are used to square roots, and your calculator's used to square roots being positive numbers. If you take a square root of a number, you're going to get a positive. The square root of 81 is 9, and we haven't even worked on that. The square root of 121 is positive 11, but that is not true. Your calculator has been lying to you, and us teachers, we have been lying to you. It is not just positive numbers. Square roots also are representative of negative numbers. So this symbol here, this plus and minus sign put together, that means positive or negative. Whatever number you're putting out there, you're having both situations in occurrence. It could be either positive or negative, and you have to take both into account. So you're actually doubling your work all of a sudden by putting in this plus minus. So there's two answers. In an example, 9 times 9 is also written as 9 squared. 9 squared is 81. We know that. So 9 squared is 81. However, if we have negative 9 times negative 9, that's the same as negative 9 squared. That is also 81. The term square root means what number times itself is this number. So the square root of 81 says what number times itself is 81. Well, we just showed that there's two possibilities. Positive 9 times positive 9. So positive 9 squared or negative 9 squared both equal 81. There's two answers, plus or minus. So it's either 9, the answer to this is either 9 or it's negative 9. There's two answers. It's important to note because as we move forward in this unit, we're going to be using what's called the quadratic equation. We're going to factor those unfactorable equations, and this is going to be a very important concept as it's included in that equation. Okay, moving on. Going back further into some previous units and going back into the unit before we took a break, we have changing the forms of the different types of a quadratic. So we've done moving from standard to factored form. Here's a standard form of a quadratic equation. Y equals negative 16x minus 63. We can convert this to a factored quadratic. We do this by using the factoring of a simple trinomial. This is a simple trinomial because there's no number in front of the x. So if we do this, we look for two numbers that add to negative 16 and multiply to negative 63. Again, you can make a list of numbers along the side of your page beside the question. Try and figure out which to satisfy both conditions. They add to negative 16 and multiply to negative 63. Knowing that they multiply to negative 63, one of these numbers has to be negative. So one's going to be negative, one's going to be positive. Two numbers that multiply to negative 63 and also add to negative 16. And I screwed that up because that won't work. Let's fix that. Multiply to positive 63. Now we have some numbers to work. So thus our numbers are going to be both negative. Two numbers that add to a negative number and also multiply to positive have to be negative. That fixes that question. So what multiplies to 63? Well, off the top of my head, knowing my multiplication chart, 9 and 7. 9 and 7 multiply to 63. 9 and 7 also happen to, if they're both negative, make 16. Negative 9 minus 7 is negative 16. So that's my pair of numbers. So I set a pair of brackets out. Both of them start with an x. And then I put those two numbers in, negative 9, negative 7. Or negative 7, negative 9. Doesn't matter the order. As long as you have x minus 9 and x minus 7 in a bracket, doesn't matter the order. This is the first set that works. Again, change that to a positive 63 because I miscopied my question down from my other page that I actually made sure this worked. But we need to be able to do both things. Multiply positive 63. Negative 9 times negative 7. 9 times 7 is 63. Two negatives make it positive. We're good. Negative 9 minus 7 is negative 16. Two negatives. We're getting smaller. Smaller negative numbers look bigger in terms of the digits, but not in terms of the whole expression. And so we're good. So this works. Now, on top of simple trinomials, a method that actually works for simple trinomials as well is working with complex trinomials. And this is when we throw a number in front of the x squared. So here we have 12x squared plus 19x plus 4. So that 12 in front makes this very different from the question we just did. We have to concern ourselves first with multiplying the 12, the coefficient of the first term, by the coefficient of the second, or the last term, the third term, which is 4. So 12 times 4 is going to get us 48. And so we're looking for two numbers that multiply to 48 and add to 19. Both positive numbers, so our solution here must be both positive numbers in the terms that we're looking. And in terms of this 12x squared, two numbers that multiply to 48, add to 19 happen to be 16 and 3. 16 plus 3 is 19. 16 times 3 is 48. So I'm going to rewrite this equation, replacing the 19x with 16x plus 3x plus 4. So I've replaced the 19 with these two terms right here, 16x and 3x. Order does not matter. Again, you could put 12x squared plus 3x plus 16 plus 4. It does not matter because come the end, we're going to get the same answer because it's a multiplicative answer, and the multiplication does not matter which order you put it in, as in the same situation as the last question. So the next step here, we're going to take these first two terms and common factor. This is called factor by grouping. We're going to group the first two terms together and factor them. 12x squared and 16x both have a common factor of 4. 4 goes into both 12 and 16. And then if I look at the letters, the x squared and x both have a common factor of x. And when I divide that out from the first two only, I'm left with 3x plus 4. So that first term factored. Now looking at the next pair, 3x plus 3x plus 4. I bring down the sign of the first term. Plus 3x plus 4. Factoring those, the only common factor is 1. So I'm going to put a 1 down here, and I'm going to divide both by 1. Well, it just leaves me with 3x plus 4. Dividing by 1 does not change anything. Now, looking at this, I have two terms. Again, terms are separated by plus and minus signs. I have 4x times 3x plus 4, and then I have 1 times 3x plus 4. Common factor. Common factors, meaning common number that multiplies into both terms, is 3x plus 4. I'm going to factor that out. 3x plus 4 gets factored out, and 4x plus 1 is left over remaining, and thus this is our final solution for this one. So this is one of the other, this is factoring a complex trinomial. This also works for factoring a simple trinomial. It'll also work in the other two examples if you add a plus 0x and a plus 0 respectively into them. If this is the method you want to use, and I've taught in times that people have used just this one method and it's worked, and if they understand the one more complex method, but it's the one thing they have to know, sometimes it works. So you can convert the other two into this. This could be written as 64x squared plus 0x minus, there should be minus, eraser, minus 9, and this could be written as 14x squared minus, that's a 7x first, 7x plus 0. Both of these you could factor the same way as the previous b. You could factor both these the same way as b if you wanted to. You don't have to though. I'm going to actually get rid of that because we're going to show you the two other methods of factoring trinomials. Are these trinomials? Yeah, because I just showed you that if you put a plus 0 and a plus 0x in there, they're trinomials. But we have these x squareds in there. That means that we can factor these in the same kind of manner. Y equals, in this case here, we have this difference of squares. 64 happens to be a perfect square. X squared is a perfect square. Minus means difference, and 9 is a perfect square. This is a difference of squares. So in factoring a difference of squares, the shortcut method is to set up yourself two sets of brackets. Square root the first term. Square root of 64 is 8. Square root of x is x. So I'm going to put that at the start of each parenthesis set. Then I'm going to add a plus and a minus. And then the square root of 9 is 3 in each case. There we go. We just factored that. That easy. Difference of squares, nice and easy. You look for square roots as long as there's a minus in there. It does not work if there's a plus sign there. It will not work. However, given a plus sign in front of them, in between them, we can do some factoring as well. Sometimes you can common factor them. Sometimes you can't factor them in its standard form. And that's it. However, we are able to factor this one. Next one. There's a plus in between, so we're definitely not doing any difference of squares. And the last term and the first number, coefficient, are not perfect squares. So what do? Well, if we look at that, 14x squared plus 7x. 14 and 7. They're both divisible by 7. That's a common factor. So we can divide both by 7. And then x squared and x, they both divide by x. You can divide both by x and get something. X is our next common factor. And thus, when we divide each term by that, 14x squared divided by 7x, well, 14 divided by 7 is 2. X squared divided by x is x. And then 7x divided by 7x. It doesn't cancel it out and make it 0. It divides it. How many times does 7x go into 7x? That means that there's one time it goes in. And thus we're left with a plus 1. So 7x times 2x plus 1 in parentheses. If you take that and you actually expand that out, which we're going to do in the next type of question, then you should get back to the same answer. So there's 4 ways of converting standard to factored form. Factored form to standard form, which is what we did even previous to standard to factored, is that we expanded these out. In the case of A, and I'm actually working in reverse order here in a lot of cases, we use the method of FOIL. We have two binomials. There's a binomial, 1, 2 terms. Bi meaning 2, and so binomials are two-term statements times a binomial, 2 terms. What we do is use the word FOIL. First, outside, inside, last. So we multiply 4x by 3x. We get 12x squared. We multiply the numbers, we multiply the letters. Then we multiply 4x by negative 2. 4x times negative 2 is going to give us negative 8x. Then we do 6 times 3x. Positive 6 times 3 is positive 18x. And then 6 times negative 2 is going to give us positive times negative is a negative number. And we have 12 when we multiply 6 by 2. And then we combine all this together because these two terms in the middle are common. They're like terms. Negative 8 plus 18. So we have 12x squared. And when we have negative 8 plus 18, we're going to move up to plus 10 minus 12. So 12x squared plus 10x plus 12, we have a trinomial. That's our result. In the next case, moving from factored to standard form, we have y equals 2x times x plus 7. We have a monomial, mono meaning 1, times a binomial, meaning, again, 2x minus 7. So when we do this, similar idea, we're going to just multiply both of these terms by 2x. So 2x times x is 2x squared, and 2x times negative 7 is 14x. Boom, there's our trinomial, because we could imaginarily put the plus 0 at the end. Do we normally do that? No, we don't do that because it's extraneous and takes up space. That looks cleaner. There's our equation. Now, moving from vertex to standard form. If we were given a vertex form, in this case, here we have an h value. There's no k, there's no a. All we got to do is multiply this by itself because it's squared. So it's x minus 4 times x minus 4. That's what squared means. Multiply it by the number by itself. Well, this is the number, x minus 4. We multiply that out, and we just use the same method we used up here. We use FOIL. X squared, and then x minus times minus 4, and then negative 4 times x, and then negative 4 times negative 4, and boom, we combine those middle two terms because the middle two terms have a like term value of x, not just because of the middle terms. -8 minus 16. Actually, it's plus 16. Sorry, two negatives make a positive. So there is our vertex to standard given a squared value with just an h. Now, what if all of a sudden I throw in everything? There's an h, there's a k, there's an a. Oh my gosh, there's so much. Well, let's start with the squared portion. So the 3 is still going to be multiplied there. X plus 2 times x plus 2 and minus 6. So I just rewrote that. Do you have to rewrite it? No. If you can do it in your head, awesome. But I rewrote it. So now I'm going to multiply those out. X plus 2. So x squared plus 2x plus 2x plus 4 minus 6. Y equals -3. X squared plus 4x plus 4, and then the minus 6. Clean that up. Now, I'm going to multiply everything in the parentheses by the -3. Just doing some bed mass. This is all bed mass. That's what we're doing right here. So we got -3x squared plus, no, minus 12x minus 12. And when we multiply all 3, and then minus 6 at the end. And then we just finally combine those last two like terms, -3x minus 12x and minus 18. Boom. There we go. We got a complex trinomial for ourselves. -3x squared minus 12x minus 18. The only difference you've seen in all the questions that I've done compared to what we did in the unit before the break was that I added the y equals in front because we're focusing these down to a quadratic equation rather than just a simple equation. So these are all now quadratic equations. These are all graphable equations. Now the last conversion that I have not talked about yet is standard to vertex. And you'll notice what? I have nothing there. There's no question. Why? Because I haven't taught you it yet. We're going to cover it in this unit. It requires a different type of equation, and when or a different type of method that we will look at in the coming days, or in the coming lessons, I guess. So we will cover this later. All right, if you want some stuff to do that will help you practice with some of these and review some of this, I've added some questions to the textbook section, and you can try any and all of the questions if you want from section 6.0 Get Set. It does have a nice little summary of some of the key terms and concepts that you're going to be using in the unit again. It does say in a couple cases to use a graphing calculator to check your answers. Most of you probably don't have access to a graphing calculator. Use Desmos. Go to desmos.com, D-E-M-S. Let me double check that. I want to make sure I'm saying that and spelling that right. DESMOS.com. Go there and you can try to do some graphing if that helps out instead of a graphing calculator. That's everything. Again, questions, send me them on Edsby. Send me them via email, and we will continue into Unit 6 and some new content in the next few videos.